Let's jump right into it. Number 8. Plants have their own version of the internet, and it's been running for millions of years before we even invented the wheel. Underground, there's this massive network called the mycorrhizal network, where fungi act like biological cables connecting tree roots across entire forests. Think of it like nature's version of fiber optic cables, except instead of sending emails, trees are sharing nutrients, water, and warning messages about insect attacks. When a Douglas fir gets attacked by beetles, it literally sends chemical SOS signals through this underground web to neighboring trees, who then start producing defensive compounds before the beetles even arrive. It's like having a neighborhood watch system, where everyone gets a heads up about burglars before they hit your house. Scientists call this the wood wide web, and it's so sophisticated that mother trees actually recognize their own offspring and send them more resources than stranger seedlings. Number 7. When you walk through a freshly cut grass lawn, that sweet smell isn't just pleasant, it's actually a plant screaming in terror. That distinctive fresh grass scent is made up of chemicals called green leaf volatiles, which are essentially the plant equivalent of a horror movie scream. Grass releases these compounds when its cells are damaged, and it's not just random, it's a calculated distress call. Other plants in the area pick up on these chemical screams and immediately start ramping up their own defenses. It's like if you could smell fear, and that smell made you instantly more alert and ready to fight. But here's where it gets really wild. Other plants can actually learn to recognize specific danger signals. Corn plants that have never been attacked by caterpillars will start producing defensive toxins just by smelling the chemical distress calls from corn plants that are under attack. They're literally learning about threats they've never personally experienced through airborne chemical conversations. Number 6. Trees have been practicing social distancing long before it was cool, and they do it with remarkable precision. If you look up at a forest canopy, you'll notice something called crown shyness, where tree branches seem to magically avoid touching each other, creating intricate patterns of gaps and channels. This isn't accidental, it's trees actively communicating their personal space boundaries. Some scientists think trees release chemical signals that essentially say, "Back off, I'm growing here," while others believe they can actually sense when their branches are getting too close to neighbors and adjust their growth accordingly. It's like having an invisible force field around each tree that prevents overcrowding. But the really mind-blowing part is that trees seem to coordinate this behavior. They're not just randomly avoiding each other. They're creating optimal spacing patterns that allow maximum sunlight penetration for the entire forest community. They're essentially engaging in urban planning at a level that would make city designers jealous. Number 5. Plants can recognize their relatives and treat family members completely differently than strangers. Sea rocket plants grown next to their siblings will actually restrain their root growth to avoid competing for resources, essentially practicing plant family values. But put that same plant next to an unrelated sea rocket, and it becomes aggressively competitive, spreading its roots wide to hoard water and nutrients. It's like the difference between sharing your lunch with your brother versus trying to grab the last piece of pizza from a stranger. Scientists discovered this by planting related and unrelated sea rockets in the same pots and measuring their root behavior. The family plants were polite and reserved, while the stranger plants went full gladiator mode underground. How do they even know who's family? Plants can actually taste their relatives through chemical signatures in the soil. They're literally performing genetic testing through their root systems, which is more sophisticated than what most humans can do without a lab. This family recognition system exists in dozens of plant species, suggesting that plant social intelligence is way more advanced than we ever imagined. Number 4. Some plants have figured out how to hire bodyguards, and their recruitment strategy is absolutely diabolical. When lima bean plants get attacked by spider mites, they don't just sit there and take it, they release specific chemical cocktails that essentially put out a classified ad for predatory mites. These chemicals are so precisely crafted that they attract only the exact species of predatory mites that eat spider mites, not the ones that might cause other problems. It's like being able to call for backup and having exactly the right type of specialized help show up every time. But the lima beans don't stop there, they actually change their chemical signals based on what type of attacker they're facing. Different bugs trigger different chemical SOS calls, each designed to attract the most effective natural enemy for that specific threat. Tomato plants do something similar. When attacked by caterpillars, they release chemicals that attract parasitic wasps, which then lay their eggs inside the caterpillars. The wasps get a nursery for their babies, the caterpillars get eaten from the inside out, and the tomato plant gets revenge. It's biological warfare orchestrated through chemical communication, and plants have been perfecting this strategy for millions of years. Number 3, plants can actually count, do math, and make complex decisions that would challenge most humans. The Venus flytrap doesn't just snap shut when anything touches it, it actually counts trigger hair touches and performs calculations before deciding whether to close its trap. Single touch does nothing, 2 touches in quick succession might cause a partial response, but 3 touches within 20 seconds triggers the full trap closure. This isn't just a mechanical response, the plant is literally processing information and making cost-benefit analyses. Closing the trap uses enormous amounts of energy, so the Venus Flytrap has evolved to be absolutely certain that what it's catching is worth the effort. But it gets even more sophisticated once the trap closes. The plant continues counting additional struggles from the prey inside. More movement triggers the release of digestive enzymes, but only if the plant calculates that the meal is substantial enough to justify the metabolic investment. It's performing real-time resource management that would impress any efficiency expert. Some researchers have even shown that Venus flytraps can remember previous experiences and adjust their trigger sensitivity based on whether past captures were successful or just false alarms from raindrops or debris. Number 2, certain trees have mastered the art of playing dead so convincingly that they fooled scientists for decades. When faced with extreme drought conditions, some oak trees will enter a state called hydraulic failure, where they essentially shut down all their vital functions and appear completely dead. Their leaves turn brown and fall off, their branches become brittle, and all detectable biological activity stops. Underground, the root system maintains just enough activity to keep the tree technically alive in a state that's basically plant hibernation. These apparently dead trees can stay in this zombie state for months or even years, waiting for conditions to improve. When adequate rainfall finally returns, they literally resurrect themselves, sprouting new leaves and resuming normal growth as if nothing happened. The communication aspect comes in because these trees somehow coordinate their playing dead strategy with other trees in their network. Entire groves will enter dormancy together and emerge together, suggesting they're sharing information about environmental conditions and making collective decisions about when to shut down and when to reboot. It's like having a neighbor agreement about when to go into lockdown and when it's safe to come back outside. Number 1. The most disturbing plant communication discovery is that some species can actually hijack other organisms and turn them into unwilling messengers. Certain parasitic plants can tap into their hosts' chemical communication systems and essentially ventriloquize through them. The daughter vine, which looks like orange spaghetti draped over other plants, doesn't just steal nutrients from its hosts, it actually integrates with their chemical signaling networks. And the daughter detects threats like herbivorous insects. It can trigger its host plant to release specific chemical warnings that spread throughout the area. But here's the truly sinister part: the daughter can manipulate these signals to benefit itself, essentially using its host as a biological puppet to communicate with other plants in ways that improve the daughter's survival chances. Some researchers have found evidence that certain parasitic plants can even influence their host's behavior to make them more attractive to the parasite's preferred pollinators or seed dispersers. It's like biological mind control achieved through chemical hijacking, and it suggests that plant communication networks might be far more vulnerable to manipulation and deception than we ever realized. The idea that plants can essentially hack each other's communication systems opens up terrifying possibilities about how sophisticated their social warfare might actually be. I'll make similar videos in the future. Subscribe to see them.